All right, here is the meat and potatoes of both the 6.5 and the 6.6 lesson. We are going to be graphing with two variables, so we're basically graphing linear inequalities, full-blown graphing linear inequalities. Here are the rules, students. Here we go. First things first, where does the line go? That's good old-fashioned just graphing the equation by using a slope and a y-intercept, or the y-intercept and the slope. Here's the only thing that's really new, and these rules are all kind of interchangeable. I just like to know where the line goes and then what type of line to use and then which side to shade. So the second part is, what kind of line do I use? So just like regular inequalities from not long ago, remember, like if it was x is less than 3, that would be an open circle on 3 and you'd go to the left. If you had like x is greater than or equal to 5, you would have a solid dot on 5 and you'd go to the right. So remember those from not too long ago? The same thing kind of applies with linear equations, okay, or linear inequalities. When it's a less than or a greater than, one of these the single ones, the lone ones, you must use a dashed line. It's just like this one, you didn't use the boundary number. This one's saying you cannot be on the boundary line. You can't be. It's a dashed line means no. You can't include it. The solid dot, if you remember, says, yeah, you could include that number. Well, that's what a solid line does. A solid line says, yes, the boundary line is okay. The numbers on the boundary line work. The numbers on this boundary line fail. All right, so basically you got to figure out, where does it go? Which type of line do you use, which is easy to figure out. You just look at the symbol. So right away, oh, look at that symbol. I'm going to use a solid line. Oh, look at that symbol. I'm going to use a dashed line. That's really easy. The one that's a little bit tricky is, after that, you got to figure out what side do you shade. Which side do you shade? Do you shade the top side or the bottom side of the line? I like to use the idea that the less thans, you would shade the less than side of the line. And you may be like, well, what do you mean the less than side? You'll see. Greater than means you would shade the greater than side. Or you could also do a 0, 0 point test. So here's how you do that. You would plug in 0, 0. If it works, you graph the side where 0, 0 is. If 0, 0 fails, you graph the other side. So I'll do one of each here really quick. So let's work backwards here. Now that you have the rules, let's go right to this one here. All right. So where does the line go? Well, it's y is less than or equal to a half x plus 1. So I already know it's going to be a solid line, so I kind of skipped a step. Now I'm going to graph the less than side. So where does it go? I pretend just for a second it's y equals 1/2 x, because that's where the boundary line is going to go. The symbol has nothing to do with the location. What helps you locate it is the y-intercept and the slope. So we have a slope of 1/2 and we have a y-intercept of 1. So here we go. There's 1. A slope of half means rise over run, so it means I would go up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2, and then I'm going to reverse it and go back this way, like so. Okay, so that's where my line goes. Now, before I graph it, I got to double check. What type of line do you use? Solid line, because that's what the symbol says. It says, hey, the equation's got to be less than or equal to, the coordinate point's got to be less than or equal to, so since it's equal to, the solid boundary line says, yeah, you can be on the boundary line, it's okay. All right, where does it go? What kind of line, which side do I shade? Now it says y's got to be less than, so here's how I identified the less than side. You got to draw a vertical line through it. This would be the greater than side, this would be the less than side. Oh, okay, so I'm going to graph this side of it. Less than side, less than side. So basically, if I were to shade it, I would kind of roughly shade it like so. Don't spend 1,000 years shading it perfectly. Just make it clear enough to know what's going on. So again, less than means I would shade the less than side. You got to pick a side. Again, you can also do the 0, 0 test. Let's see here. Let's plug in 0, 0. So if I plugged in a 0, is that going to be less than or equal to a half times 0? Plus 1. Here we go. 0 is 0. Half of 0 is 0. 0 plus 1 is 1. Is 0 less than or equal to 1? The answer is yes. And there's the origin right there. I already knew that. Okay, so if the origin works, if 0, 0 works, shade that side on where it is. If the 0, 0 fails, shade the other side. Okay, here we go. Next one, or the original one, excuse me. We have y is less than x minus 2. Okay, so I'm going to put my line right here. I'm going to graph it where x y equals x minus 2. So minus 2 is my y-intercept, slope is 1, so 1 to the right, change in the height. Now when the line is this close, honestly, a dotted line like this is just as good as a dashed line, so you can just leave this one like that. Okay, so make sure you don't draw a solid line, because if you're doing something in pen and it was supposed to be dashed, it's going to be kind of hard to go back and do that. So here we go. All right, where does it go? We got it. What type of line do I use? I'm already good to go. Dotted line, dashed line, it's the same thing. Y is less than. So where is the less than side? Well, this would be the greater than side. This would be the less than side. So this side, down here, I would graph the less than side. So if I were to make a nice little shading, again, don't spend forever. Don't waste all your ink. Don't waste all your lead. Just shade it enough to figure it out. There you go. We could also do the 0, 0 point test. So it looks like this time the origin fails. Well, let's try here really quick. So 0 is less than 0 minus 2. Again, what am I doing? I'm putting in 0, 0 into the equation. I'm doing a point check. You should know how to do that. 0, is that less than negative 2? The answer is no. Weird. So when the origin fails, you graph the other side. I already did that. Good job. So the point check and the less than, greater than idea also works. So that's it. That's basically everything you need to know in lesson 6.5 and 6.6, because 6.6 is just literally if you had to put these two together on the same graph. So you just do the same thing twice. 6.6 is just 6.5, but you just do 2 on 1, sometimes 3 on 1. Okay, so yeah, that's about it. I'll do a few more examples and we're almost done with these notes.